This is a video lesson on how to multiply and divide rational expressions. So here's the procedure. Working with rational expressions always has the step of factoring. And we factor denominators to be able to find the restricted values, which is step number 2. And we factor the numerators to see if there's anything that we can cancel. Because remember, you can only ever simplify or cancel factors that are multiplied, things that are multiplied at the top and the bottom. For division only, remember that dividing a fraction is the same as multiplying by its reciprocal, so you would flip it and then state restrictions for the new denominator and add them to the list, and finally reduce by canceling common factors. So I'll show you what I mean by that. When it says simplify the following expression, it is implied that you always have to state restricted values. The first thing to do is to factor everything. So if you want to pause the video and try to factor these on your own, that would be great practice. I'm going to skip right to the factored versions. So here we go. You factor these. This is a difference of squares. This has a GCF. This is a trinomial, and this has a GCF as well. So I factored everything. The second thing to do is to state all the restricted values. That means that look at each individual factor in the denominator, only the denominator do we care about, and list what value of x or the variable is disallowed because it would make the denominator 0. So in this case, our restricted values are -6, +2, 0, and +6. If you put them in set notation brackets, that would be even better. So that's step 2. Step 3 is that in the case of a division, which this isn't, I would flip this fraction because dividing by a fraction is the same as multiplying by its reciprocal, its flipped values. That step is not applicable here because this is just a multiplication. And so now we would just reduce. And by reduce, we mean look for factors that are common on the top and the bottom. Now remember that when you multiply fractions, it's as if all the numerators are multiplied together and all the denominators are multiplied together. That means that all of these are really as if they were in one line, and all of these are in one line. So a factor like x minus 6, though it was in the first expression and the second expression's numerator and denominator respectively, those still cancel out because all of these are multiplied together. It's as if they're all in a line together. So those ones cancel out. X plus 6 cancels out, and x cancels out, satisfying to do that. And then you're left with two factors that do not cancel. And don't try to cancel those x's because now they are added, subtracted, they're not multiplied. So our answer is the reduced version, including all the restricted values, even on the factors that had canceled out. That is the answer. So just to show you that this is an important factor, if we had had a slightly different expression, just to highlight what was different is that here there's an x minus 6 and here there's a 6 minus x. They're almost the same, but not exactly the same. My restricted values would still be -6, 2, 0, and 6. Because here, if I solve for this equation to be equal to 0, my x value would still be 6. But now these two factors, which are almost the same as each other, but different, the signs are different. This has a positive x and a -6. This has a positive 6 and a negative x. Those two factors are the same as this. These differ by a factor of -1. If I multiplied this out, I would get 6x and minus x squared. And if I multiplied these out, I would get -x squared plus 6x, the same thing as this. Though this looks a little bit different because it has a minus sign, these are in fact equivalent. And why would I do that? Well, I would do that because now I have an x minus 6 and an x minus 6. Basically what I'm saying is that the short version is that I can cancel out factors that are the opposite of each other, that have opposite signs, but it means introducing a negative sign. I would have a negative either on the top or the bottom or in the middle. That would be the only difference between those two. So if you want to try example 2, this one is a division. Again, if you'd like to pause for a moment to factor everything, that would be great practice. I'm going to skip right to the factored version. Factored, this looks like this. I factored everything there. I would state restricted values, which in this case, there's a can't be equal to 0. A cannot be equal to 1/2. That's the same one here, so I only need it once. And also a cannot equal 2. I only work from the denominator. But step 3 was for division only. Dividing by a fraction is the same as multiplying by its reciprocal. That means that this division is the same as this multiplication. So I simultaneously change the division symbol to a multiplication, and I flip the second fraction. So I multiplied by its reciprocal. that adds a new restricted value because there's a new term in the denominator that was not there before. Now a can also not be equal to 5. So I've got to add a new restriction. I had those original ones, and I have this new one. It's possible that I could have 2 new ones or 3, but here I only had 1. So all of the things that were already there stay there. So even something that moves up to the top, if it was originally in the denominator, that still contributes to the restricted values, and now I have a new one. And now I skip to step 4, which is to reduce, to look for common factors on the top and the bottom, cross all of those out. Oof, this one crosses out too. Lovely. If in a case like this that you are left with nothing, because all of these were multiplied, it really means that when you're dividing two of the exact same thing, you're left with just 1. That's the answer. And all of those restricted values apply. That's it.